In the last video, we looked at solving some basic trig equations. In this video, we're going to look at some slightly harder examples where we have multiple or compound angles. Let's look at an example of an equation that we might have had in the last video. We might have had sine of x is equal to 1/2, and we needed to solve for x in the interval from 0 to 360 degrees. Another example, we might have had cos of x is equal to negative root 3/2, and we might have been asked to solve for x in the interval from 0 to 2 pi radians. We were looking at both degrees and radians and how to solve in a given interval. If you haven't seen that video, please check it out, as this one relies on the knowledge gained from that video. So let's look at some examples of the equations that we might solve in this video. We might have, for example, sine of 2x is equal to 1/2. So instead of just solving for x, we're now solving for 2x. And again, we'd be given an interval. So that interval might be from 0 to 360 degrees, 0 to 180 degrees, negative pi to positive pi. It all depends on the question. Another example might be tan of 3x is equal to 1/√3. Again, we'd be given an interval to solve for x. Another type of equation we might see could be tan of x minus 15 degrees, and that could be, for example, equal to 1. So this time we don't just have x, we have x minus 15 degrees. We might have, for example, cos of x plus pi by 4. So this time an angle in radians, and that might be set equal to, let's go for 1/2. So these are just arbitrary values I'm choosing for the right hand side. A more complicated equation might be sine of 3x plus pi by 3 is equal to negative 1/2. So this time we got 3x plus pi by 3. What I'm going to do is use exactly the same approach as I did in the previous video and simply go ahead and solve these equations for x or theta in a given interval. So, as stated, if you haven't seen my last video, please check it, as I'm going to assume a base level of understanding of how to solve this type of equation. Let's start. We're asked to solve the following equations in the interval for x between negative and positive 180 degrees. So in A, we've got sine of x minus 30 is equal to root 3/2. What I'm going to do here is get a principal value for the angle x minus 30. Some people consider changing the interval to suit that angle. I just find a general solution and then by symmetry get the next, and then look at now the period of the graph and add multiples of 360 either way. So let's go ahead and do that. So what we can say then, principal value, as we looked at in the last video, x minus 30 will be equal to the inverse sine of root 3/2. This is one of our special angles. We can get it on a calculator, or we can just compute it ourselves. I know that's 60 degrees. If you're unsure, just check. Perfectly fine to do that. Shift mode 3 puts you in degrees, and then we're going to do the inverse sine, shift sine, and then we'll have root 3/2. So principal value for my x minus 30 is for 60 degrees. So we can say x minus 30 is equal to 60, and then we're going to have plus or minus multiples of 360 degrees. By symmetry, if I have one 60 degrees in, I'm going to have 60 back from 180 as it's a sine curve. So what we're going to have, x minus 30 is also equal to 120 degrees plus or minus multiples of 360. And that is my starting point. Remember, sine x is equal to sine of 180 minus x. And we can see that graphically as we did time and time again before. If I've got one here at 60 degrees, then I'm going to have one at 60 back from 180, which is going to give me 120. We can see that this point is a line of symmetry. All I'm going to do now is just add the 30 degrees. So x is going to be equal to 60 plus 30, which is 90, plus or minus multiples of 360 degrees. If I consider the bottom one, adding now the 30, x is going to be equal to 150 plus or minus 360 degrees. So if I now look at this one, I've got x is equal to 90 degrees. If I add or subtract multiples of 360, I'm going to clearly go outside the interval of negative to positive 180. So this is the only solution that comes from this equation. If I added 360, that would take me to what, 450? If I subtracted it, we'd have negative 270. Both are not valid. If you want, you can substitute in values of n. In case n is 0, we get the 90. If n is 1, n is 2, n is negative 1, and so on and so forth. This one just here, this will yield now for 150. But again, if we add or subtract multiples of 360, we go outside that interval. That's done. We're sorted. Some people would have solved that by switching the interval initially. Some may have solved it even graphically, considering that this is just a horizontal translation of 30 degrees to the right, or if you like, in the positive x direction. I just like to solve it in this particular way. We know the symmetry of the curve, 60, 120, and we know it cycles every 360. Okay, let's do the next one. So what we've got here is cos of x plus 45 is going to be equal to 1/2. So principal value. So what we've got is a principal value for x plus 45, and that will be equal to the inverse cosine of 1/2. This again is a nice value, and again it gives us 60 degrees. If you want to check, you can do it. We're in degrees mode. Shift cosine, shift cos of 0.5, 60 degrees. So x plus 45 is equal to 60 plus or minus multiples of 360 degrees. That now is our first equation. Our second equation is x plus 45 is equal to 60 back from 360, which is 300, plus or minus multiples of 360 degrees. If you're looking at that thinking, where's this 300 come from? It was clearly outlined in the last video in terms of a cosine curve. If we have cos of x, this is the same now as cos of 360 minus x. Graphically, we have now the symmetry, and the symmetry is just here. So if I've got one just here at 60, then I've got one at 60 back from 360, which will be 300. Okay, so let's just go ahead with this one, and what we're going to do is subtract 45 from each. So x is going to be equal to 15 plus or minus 360, and x is going to be 255 plus or minus 360. Okay, so all I'm doing is just finding these general solutions. We're interested in this from negative to positive 180. Clearly the first one is just going to yield 15 degrees. So 15 degrees, adding or subtracting multiples of 360 will quite clearly take me outside the interval. This one just here, 255, is too far. We're only interested in going up to 180. So what I'm going to do is subtract a multiple of 360. So if I put n is equal to negative 1, if you like, that's going to give me now 255 minus 360, and that will give me negative 105. So they are the two solutions in the interval. So all I've done is consider now general solution, gone ahead and then looked and said to myself, I know the curve cycles every 360, so I'm just going to add or subtract multiples. Okay, next one, 3 tan of x minus 15 degrees is equal to root 3. If I said now, for example, 3p is equal to root 3, we would divide both sides by 3. That's exactly what we do here. So what I can write is that tan of x minus 15 degrees is equal to root 3 over 3. That's again a nice value. So if we look at principal value, x minus 15 degrees is going to be equal to the inverse tan of root 3 over 3. Initially, we're working with very, very nice numbers. It won't always be that way. We might get something very messy on the right-hand side, like negative 0.12. It's just initially when we're doing these, I like to start off with nice examples that work nice and cleanly so you can get the technique. So x minus 15 degrees is equal to the inverse tan of root 3 over 3, which is 30 degrees. Again, check it on the calculator if you wish. Tan cycles every 180, so plus or minus 180n. We've seen this before. Tan of x is equal to tan of 180 plus x, or x plus 180. Graphically, if you drew that for tan curve, again, we saw this before, does something like that. So let's say I've got this one just here at 30, the next one is going to be 180 on, the next one is going to be 180 on, and so on and so forth. So all we're dealing with is this equation right here. So adding the 15 to both sides, x is equal to 45 plus or minus multiples of 180 degrees. So that's what we have. So from this we can see that x would be equal to 45. If I subtracted, if I added 180, I'll go outside the interval. If I subtract 180, I will be inside the interval. So subtracting 180 is going to give me negative 135 degrees. There are two solutions. I'm just considering now that I need to go backwards here. So what we've got is something that looks like that, and then we'd have this one just here. So all I'm doing is going back to now solve just here by subtracting now the 180 degrees from the 45, and that gives us negative 135. Really, I'd list these out with negative 135 before, so I'd like to leave my answer as x is equal to negative 135 degrees, x is equal to 45, and then any subsequent solutions that we did have in the interval I would just put after the 45. Okay, let's have a look at this one. We got 2 sine of x plus 60 is equal to root 2. So we can say now sine of x plus 60 degrees is equal to root 2 over 2. So principal value, we can say that x plus 60 degrees is equal to the inverse sine now of root 2 over 2. Again, a nice value here. X plus 60 is equal now to 45 degrees plus or minus 360 degrees. So we're just adding or subtracting multiples of 360. By symmetry, x plus 60 will be equal to 45 back from 180, 135 plus or minus multiples of 360. That now gives us our starting place. So all I've done here is hit now inverse sine. So inverse sine of root 2 over 2, that gives me the 45 degrees. And then all we're going to do on these is simply go ahead now and subtract the 60. So x is going to be equal to 60 from 45, which is going to be negative 15, plus or minus multiples of 360. X is going to be equal to, what's that going to give me, 75 if I subtract that from there. X is going to be equal to 75 degrees, so let's just put that on 75 plus or minus now 360n. So with this one, let's have a look at what we're going to have. We can see now that x is going to be equal to negative 15 degrees. We're not going to have any solutions clearly beyond that and before that. And then this one right here, this is just going to give us 75. I could write it below, I could write it on the same line, it really doesn't matter. 75 degrees and negative 15. So I'm not swapping any intervals to begin with, I'm simply solving now in this given interval by bringing them back in with a general solution. So these are our two solutions. Okay, we asked to solve the following equations in the interval from 0 to 2 pi. So we're looking this time at radians. So in part A, 2 cos of x plus pi by 3 is equal to root 3 over 2. So what I'm going to write then is that cos of x plus pi by 3 is going to be equal to root 3 over 2. Taking the inverse cosine, what we'll have, principal value of for x plus pi by 3. Now pi by 3 is 60 degrees. When you're working with radians, learn radians. Don't try and write that as 60 degrees because often you'll be asked of these as a multiple of pi. And if you start truncating or approximating answers, you're going to lose that exact value. Okay, inverse cosine of root 3 over 2 in radians is going to give me pi by 6 plus or minus multiples of 2 pi n. 360 degrees, principal value. So if we switch this up, what we'd have, if we put it now shift mode 4, you can use calculator of course, inverse cosine now of root 3 over 2. So root 3 over 2. In later examples, I will be heavily relying on the calculator here. So there's my pi by 6. If you're unsure at the next one, all you're doing is subtracting pi by 6 from 2 pi, which should give us 11 pi by 6. If you're unsure, 2 pi, 2 shift pi, minus the answer, and that gives us the 11 pi by 6. So pi by x plus pi by 3 will also be equal to 11 pi by 6. That's the symmetry of the cosine curve. If I've got one 30 degrees in, I've got one 30 degrees back from now the 360. Right, okay, this is 2 pi by 6. So, sorry, 2 pi, 2, let's just write that, that's 2 pi by 6. So if I subtract it, we're going to get, that should be negative pi by 6. Again, if you're unsure, just put it into the calculator. It's fractions. All I'm doing here is essentially doing 1/6, so 1 over 6, and then we're going to be now subtracting from that 1 over 3, and that should give us negative 1/6. So x is going to be equal to negative pi by 6 plus or minus multiples of 2 pi. So this one, we're going to be taking this off. So this is going to give me now pi, what have we got on here? Pi by 3 from that. So that's 2 pi by 6 subtracted. That's 9 pi by 6, which would give us 3 pi by 2. Again, don't run the risk if you're unsure trying to do fractions in your head. I suppose you can. My excuse is I'm going to be talking and I want it to be right. 3 pi by 2, there we go. So x is going to be equal to 3 pi by 2 plus or minus multiples of 2 pi. So that is now the next stage. Okay, at this point right here now, we can see that negative pi by 6 is not in the interval. Negative pi by 6 is negative 30 degrees. We want this between 0 and 2 pi, or 0 and 360. So what we need to do is add the 2 pi. So if I do that, that is going to give me 2 pi minus pi by 6 is going to give me now 11 pi by 6. Sometimes you'll see the little radian sign used, more so when these aren't exact values. And then this one is going to be 3 pi by 2. That one is in the interval. So there we go. A bit more tricky because we're dealing with these exact values and fractions. And hopefully my fraction work has stood up. But do it with a pencil and paper if you wish. Okay, this one right here. So what we've got then is x minus pi by 4 is going to be equal to the inverse tan. So here's principal value 4x minus pi by 4, 1 over root 3. This again gives me a nice value. X minus pi by 4 is going to be equal to, this is going to give me pi by 6. So that's 30 degrees plus or minus multiples of pi. This is the tan curve. Remember, pi is equal to 180 degrees. So I'm not adding 2 pi. I'm not doing any other symmetry. What we've got is now pi, x minus pi by 4 is equal to pi by 6 plus now these multiples of pi. So what are we going to have here? Let's just add a 6 1/4. I should be able to do that in my head. What's that? It's going into 12. So let's just do it. So 0.25 plus, and I apologise, I'm having to do this on a calculator rather than pencil and paper. 5 pi by 12. So x is going to be equal to 5 pi by 12. Then we're going to have on here now plus or minus multiples of pi. So if I consider now, if I add another multiple of pi, x is going to be equal to 5 pi by 12. Adding the multiple of pi, that's going to give me 17 pi by 12. Just consider that 2 pi is 24 pi by 12. So by adding these multiples of pi, I'm going to have 2 in the interval from 0 to 2 pi. If I added another multiple, that would take me to 29 pi by 12, which is clearly outside the interval. And if I subtracted from that pi, it would take me now to negative 7 pi by 12, which again is outside the interval. So as you can see, these are slightly more challenging with the fractions, and perhaps I should be better with my fraction work. But again, I'll put it down to making a video. Okay, we're asked to solve the following equations for x between 0 and 180 degrees. Okay, we've now got sine of 3x is equal to root 3 over 2. We need to be very careful here. If I quickly do it now, what I'm going to do is draw the graph of sine 3x. Sine 3x now will cycle, that's one complete cycle, so this should be 0 to 360. This will do 3 full cycles, that's 2 full cycles. The third will come around, that is 360. So we can clearly see if we're solving this equation, we're going to have more solutions. So if I just put that on, that's about root 3 over 2. Let's just put that there, something like that. You can see from here that we've not just got 2 solutions, we've got 6 solutions. So how do we solve this? Well, what I'm going to do is simply say principal value. 3x is going to be equal to the inverse sine now of root 3 over 2. So again, we're dealing with something very nice. Now we're interested for this in the interval from 0 to 180 degrees. So if we consider this is now 0 to 120, that's 240 and that's 360. So that is going to be 180. So let's go ahead and look at what we're going to have here. So what I'm going to do is simply now go ahead and write that 3x, so 3, if I can write 3, let's just pop that down. So 3x is going to be equal now to, that's going to give me 60 degrees, plus or minus now multiples of 360 degrees. By symmetry, we can say now that 3x is 60 back from 180, so that's going to be 120 plus or minus multiples of 360. That is my first approach. At this stage, I now divide through by 3. I'm dividing each of these by 3. So if I go ahead and do that, what we're going to have is x is going to be equal to 20 degrees plus or minus multiples of 120. Hopefully you can see why it's 120 as we got 3x, so we're dividing the x coordinates by 3. So instead of it being now one full cycle in 360, it's one full cycle in 120. X is going to be equal to 40 plus or minus 120 degrees. So let's consider what we want. We want from 0 to 180. So what we're going to have then is x will be equal to 20. We're going to have now 140. And then, of course, we will go outside the interval. X is going to be equal to 40 degrees. Then we're going to have now, on here, we're going to have 160. So listing those out, final answer, x is equal to 40 degrees, comma, 20 degrees, 40 degrees. In fact, I'm making a bit of a mess of this for some reason. Let's write this in. 20, 40, 140. So 20, 40, 140 and 160, and they're our solutions. Now if we look at this, what we've got here now is the following. We've got the 20, we've got the 40, we've got the 140, and we've got the 160. We were solving up to this point just here. Right, okay, now we start getting a bit messy because this isn't a nice value. So what I'm going to say then is 2x, principal value. If you want to write principal value, you can do. Inverse cosine now of 0.45. This is when I'm going to start really using my buttons on the calculator. You don't have to. You might not like the way I do this. It's entirely up to you. So what we're going to do is write that 2x. So 2x is going to be equal to, we're working in degrees, so shift mode 3, and we'll do now inverse cosine of 0.45. That gives me 63.25 and so on and so forth. So 63.25 ... plus or minus multiples of 360 degrees. At this stage, I'm just going to put a little a here, and I'm going to store that in the calculator. So what I'm going to do is say shift store a. Okay, next one is 2x is equal to 360 minus this value. So 360, and I can just put minus the answer, or I can put minus recall a. Don't have to, entirely up to you. 242.74. So 242.74, Okay, so that's going to be dot, 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 and so on and so forth. And again, plus or minus multiples of 360. I'm going to call this B. Okay, now I could keep listing these out, and depending on the level of work you need to do, it's entirely up to you. Shift, store, B. So that's in as B. Recall A, that's A. Recall B, that's just there. What I'm now going to do is simply divide by 2. And at this stage, you could go ahead and give your answers. So what I'm going to do is say that x is going to be on the first one, 63.25 divided by 2. So 63.25, blah, 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 divided by 2, plus or minus multiples of 180 degrees. This is something students often forget to do. They don't split this by 2 as well. And then the next one, x is going to be the 242.74, blah, 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 divided by 2, plus or minus now multiples of 180 degrees. We're splitting this by 2. So at this stage, I simply use what's stored into my calculator and write the answers out. Again, depends on how much work you're asked to do on this. I'm just going to go ahead and do this. So we're interested in this now from 0 to 180 degrees. So you can see with these ones right now, what we're going to have now are they're going to fall outside. So it's only these ones we want. So what I'm going to do is just do recall A, so that's A, and divide by 2. And we were asked to give these to 1 decimal place in the last video. We'll do the same here. If you want to do it to 3 significant figures, you can do. So 31.6, x is equal to 31.6 degrees, and that's 1 dp. You can do it to 3 significant figures. And then the next one, what we're going to have is recall b divided by 2, and that's going to give us now 121.4. So x is going to be equal to 121. Let's just go ahead and check. So we got 121.4 to 1 dp, or if you like, 121 to 3 significant figures. So that's all I'm doing, and I'm going to rely heavily on my calculator when some of these start getting a little more messy. Right, next one. What we're going to do is write principal value. So this is about as tough as this particular unit gets. The only thing that could make this nasty is if you had a negative value and it was in radians. So what we're going to say then is 3x minus 20 degrees is equal to the inverse sine now of 0.3. We're solving from 0 to 180. So again, in degrees, which we already know, got a little d there, shift sine, inverse sine of 0.3 at 17.457. So 3x minus 20 is equal now to 17 point, I'm going to store this in so it doesn't, 457, blah, 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 dot, 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 plus or minus multiples of 360 degrees. So at this stage, I'm just going to call this A, okay, and what we're going to have now is 3x minus 20 is going to be equal to 180 minus A. So shift, store A. So we've got 180 by symmetry minus, and I'm just going to put the answer that time, it really doesn't matter, 162.54. So 162.54, blah, 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 dot, 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 360 degrees. And I'll call that one B. At this stage, depending on the level of work that you're asked to do, what I'm going to do is simply write now for the first one, x is equal to 17.457 plus 20 divided by 3 plus or minus multiples of 120 degrees. I'm showing full workings, I'm just doing it in a bit of a one hit. If we look at this one, x is going to be equal to now the 162.54 plus the 20 degrees divided by 3 plus or minus multiples of 120 degrees. I'm remembering I'm adding 20, then I'm dividing both sides of the equation by 3 each time. So here goes. What I'm going to do at this stage, I know that that's A and I know that that's B. So what I can simply do now is put recall A plus 20 divided by 3 gives me now 12.48. So let's write that on. x is going to be equal to 12.48, and I would show this in terms of my full workings, but as I'm rounding these to one decimal place based on the conditions given in the last video for all of these questions, I'd say it's 12.5 to 1 dp. Now just consider what we've got. We're interested in the interval from 0 to 180 degrees. Therefore, all I'm going to do is plus 120, and that gives me 132.5. As we could just add that on anyway. 132.5 degrees. Clearly adding another multiple will take me outside. Let's now deal with this one. What we're going to have is the following. We've got this stored in. So what we're going to have is the following. We're going to have recall B. Remember, that's the 162 point blah, blah, blah. Plus the 20. We're going to split this by 3. And that gives me now 87.58. So 87.6. I'd write the 87.58. And of course, what we're now doing, we're adding or subtracting multiples of 180. What happens? We go outside the interval. If you'd subtracted it, we would have gone outside the interval. So those are the three solutions. You might want to put them in ascending order. This one, this one, this one. So this one, this one, this one. I should say 12.5, 87.6, 132.5. Entirely up to you. Hopefully that's giving you a technique you could use. So let's do it with this one. What we're going to do is find the principal value. PV. 2x plus 12 degrees is going to be equal to the inverse tan, so inverse tan of 1.3. So what I'm going to do is simply go ahead and find that value. So we can do this now and shift tan, again we're still working in degrees, of 1.3. So that gives me 52.43 and so on and so forth. So 2x plus 12 is equal to 53.43, so let's write that down, 52.43 plus or minus multiples of 180 degrees. Right, so what I can do at this stage is simply say now that x is going to be 52.43 minus the 12 divided by 2 plus or minus multiples of 90 degrees. I've subtracted the 12 and then I've divided both sides of the equation by 2. If you want, you can store this in. Shift store A, just in case you make an error. It's no biggie if you do. So what we'll do is A will minus the 12 and we will divide this by 2, and that is going to give me 20.2 to one decimal place. So x is going to be equal to 20.2 degrees. We're now going to add a multiple of 90, so that's going to give me 110.2 degrees, and then any more will take us outside the interval. So nice and straightforward, we're just going ahead and using this particular format. Okay, let's go ahead and look at some others. We're asked to solve the following equations in the interval where x is between 0 and pi. So now we're working in radians. Most of these involve x. You might see theta, that's perfectly fine. X or theta or some other angle, it doesn't really matter. So first thing I'm going to do is go ahead and hit shift mode 4. Shift mode 4 puts me in radians. These are going to be messy. So on the first one, principal value, we're going to have 3x minus 1.2, and we've got a little here, little c to denote that it's radians, and that's going to be equal to the inverse tan, so inverse tan of 0.4. Right, so let's go ahead and do this. What we'll get then, so shift tan, inverse tan of 0.4. Let's just check I've written that down properly. There we go, 0.4. And that's going to give us now 0.38. Remember, this is radians. If we have pi radians, that's 3.14159. 2 pi radians is 6.28 whatever and ever. So this just gives you some idea of the magnitude of that. So it's not a very big angle. Okay, so what we can say then is 3x minus 1.2 is going to be equal to the value on my calculator, which is perfectly fine, 0.385, so 0.385, blah, 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 plus or minus, this is the tan curve. The tan curve cycles every 180 degrees, or pi radians. So we can put plus pi n. So what I can say at this stage now is that x is going to be equal to 0.385 plus the 1.2 divided by 3 plus or minus multiples of pi by 3. So that's what I'm going to do. And again, if you want to store this value in, you're more than welcome. Shift, store A. So let's consider now what we're going to get. Let's have recall A, and then we're going to have plus 1.2 radians. We're going to split this by 3, and that is going to give me now 0.526. I'm actually going to do this to 3 significant figures. So 527. So x is equal to 0.527 radians. So now we need to consider adding a multiple of pi by 3. So if we now add, so plus now, if we do, let's shift pi by 3, what we're going to end up is 1.57. So 1.57. So 1.57, and that's going to be in radians to 3 significant figures. Now we're interested in this between 0 and pi. So if I consider now 0 to pi, if I added another, let's go ahead and add another pi by 3. So add now another pi by 3. So add pi by 3, that is going to give me now 2.62. So 2.62 radians, that's what I'm going to write. Okay, if we think now, if I added another pi by 3, so add, let's shift, shift, there we go, I'm talking my way through it, pi by 3, that is going to give this. Now, if you are unsure, pi is 3.14159 and so on and so forth. So we've now gone outside the interval. So those are the solutions that we have. So as you can see, slightly more, and if you drew that graphically, it would probably be more intuitive to see the number of solutions that you're going to get. But in terms of if you're in an exam doing that, it's not as easy to see. Right, okay, this is going to be quite messy. 2x minus 0.2 radians is going to be equal to the inverse sine now of negative 0.12, and I'm really going to rely on the calculator. So what we're going to get then is the following. We're going to have shift sine. So you've got negative 0.12. Right. That gives me negative 0.012 and so on and so forth. So let's write this out. So 2x minus 0.2 is going to be equal to, and this is going to give me now negative, so negative 0.12 ... and so on and so forth, plus or minus 2 pi n. Sine curve cycles every 360 degrees, or 2 pi. At this stage now, we've got to consider an x solution. What we've got, the sine curve does something like this. We've got a principal value and it's just here. What I can do is minus this value from negative pi. So I can do negative pi minus this to get that next one. So let's just go ahead and call this A. So this is again a method. You might want to jump to these ones. It's entirely up to you. So shift store A. What I'm going to do now is negative pi. Let's press shift first. Negative pi minus that answer, and that gives me now negative 3.02. So what we've got then is 2x minus the 0.2 is equal to negative 3.02 blah 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 plus or minus 2 pi n. Right, I'm going to store this one as B. So let's go ahead and do that. So shift store B. So A is just there, B is just there. At this stage, what I'm going to do is just show this as my working. The next thing I'm going to do is say that x is equal to the negative 0.12 ... plus 0.2 divided by 2 plus or minus multiples of 1 pi. And x is going to be equal to negative 3.02 ... plus 0.2 divided by 2 plus multiples of pi. So hopefully you can see what I've done here. All I'm doing, instead of taking all this complication, I'm simply going to go ahead and I'm going to add the 0.2 to both sides and split both sides now by 2. Right, so let's go ahead and do that. So the first one now is going to be on here, recall A plus 0.2, and then we're going to divide that by 2. So that's going to give me that value right there. So that's the first one, and we'll do it again to 3 significant figures. So what's that going to be? 0.0399, x is going to be equal to 0.0399, and again that's the 3 significant figures. That's very, very small. Let's just check that. That looks good. Hopefully I've done that correct. Okay, and then what I'm going to do is add multiples of pi. Remember, we're interested in this between 0 and pi. Well, clearly then, if we add a multiple of pi, we're going to go outside that. So if we look at the last one that we were doing, we could see that by adding multiples of pi by 3, we weren't going to go outside it. But now what we're doing is adding multiples of pi. So that's going to be that one. That one's sorted. Right, subtracting a multiple of pi, that is going to be no good because it's going to take me outside the interval. Let's now deal with the second one. This is where I've got this value of b. So what we'll do then is recall b plus the 0.2. I'm now going to divide this by 2, and that's going to give me this. Okay, so that's going to give me the negative 1.41. What I'm going to do at this stage is add that multiple of pi to bring it back into the interval, and that is going to be 1.73. So 1.73 radians, and again both of these are to 3 significant figures. So you can see what turns from a very, very messy equation here we just deal with and go ahead and simply solve, find principal value, and then consider by symmetry and by now the cycling of the curve, or the period of the curve, what we're going to have. Okay, last one. So what I'm going to say on this one then is the following. We're going to have 3x plus 0.65 will be equal to the inverse cosine of 1.87 divided by 2. So all I've done is split both sides by 2. I'm now going to get a principal value. So divide 187 by 2, which is going to give, what's that going to give? 0.935. Let's do it. I can't even get my brain working. 1.87. 1.87 divided by 2, so 0.935. So if we do the inverse cosine of that, again, we're in radians, shift cos of that answer. So that's going to give us 3x, let's write this down, 3x plus 0.65 is going to be equal now to, what's that giving me? 0.3620.3625 dot 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 dot, and then we're going to have plus or minus multiples of 2 pi. Okay, by symmetry, if we've got this one 0.3 whatever it is back in, and we can call this one a, so that's going to be a. I would do this in pencil if it's in an exam because it means nothing to the examiner. Shift store a. So what we're going to have now, by symmetry, we're going to have the same distance back from 2 pi. This is a cosine problem. So 2 shift pi minus that answer. So that's going to give now 5.92. So 3x plus 0.65 is equal to 5.92 dot 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 plus or minus 2 pi n. Okay, call this one b. So just showing what we're doing, let's just put this in, shift store b. There we go. So a is just there and b is just there. So what we're going to say then is x is equal to 0.362 dot 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 minus 0.65 divided by 3 plus or minus 2 pi by 3n. Hopefully now you can see what I've done. I've split now, I've subtracted 0.65 and split both sides by 3. So x is going to be equal to 5.92 dot 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 dot, subtract the 0.65, divide by 3, and then we're going to add or subtract multiples of 2 pi by 3 radians. So let's go ahead and do that. We're interested in this between 0 and pi. So let's go ahead and do this. So what we'll have then is recall a minus 0.65 divided by 3, and that's going to give me this value right here. I would write that down in exam. I'd still write it down. X is equal to that plus or minus 2 pi by 3. So if I now add on here 2 shift pi by 3, we're going to get on there 1.99. So 1.998, so what's that going to round to? 2.00. If I do that to 3 significant figures, that's going to be 2.00, isn't it? So x is going to be equal to 2.00 radians. Now if we consider adding another 2/3 of pi to this, we're only interested in this between 0 and pi. I'm just checking my rounding, that's going to be 2.00, so I'm not going nuts. Plus now 2 pi by 3, so 2 pi by 3, that will take us well outside the interval, as we can see. Okay, let's now look at the next one. What we're going to have then is the following. We're going to have, this is going to be b. Remember, that's stored in as b. We've got it just there. Then we're going to subtract the 0.65. We're going to divide by 3. And that's going to give us now 1.75. So x is equal to 1.756. So 1.76. X is equal to 1.76 radians. Okay, at this stage, again, if we add 2/3 pi, so plus now the 2/3 pi, what we'll see is the following. So let's just do that. That will go outside the interval as well. So 2/3 pi, and again, it's, we're interested in pi. If you are unsure if that's gone outside, if you subtract pi, it'll give us a negative number. It's going to give us a positive number. If it was inside, we'd end up now. I'm hopefully trying to half make sense. If I subtract now a multiple of pi, it's now not negative, so it's outside the interval. Right, as you can probably see, I'm getting slightly tired from that. We've got a couple more just to look at, and then we'll go from there. Right, solve the equations in the interval from 0 to 360 degrees. 2 sine x is equal to sine x cos x. With this one, this is an absolute killer, and I've included it just to show you what to do and what not to do. If I said that x squared was equal to x, if I divide both sides by x, then what I'm going to get is x is equal to 1, which is one of the solutions. If I subtract the x from both sides, that gives me x squared minus x is 0. Factor in x minus 1 is equal to 0. So x is equal to 0, or x is equal to 1. By dividing both sides of this equation by sine x, I'm going to possibly lose solutions. We can divide in terms of providing an identity. So for example, sine x over cos x is tan x. But I'm not just going to divide this equation by sine and lose such that we get 2 is equal to cos x. I think we should have an x here as well. So let's go ahead and solve this. So what we've got then is 2 sine x is equal to sine x cos x. I'm going to subtract this expression from both sides. So what we've got is 2 sine x minus sine x cos x is equal to 0. I can factor out now the sine x. So that's going to give me sine x. And then what we're going to have now is 2 minus cos x is equal to 0. So all I've done is taken the sine x out. That leaves me now 2 minus cos x is equal to 0. If we consider here sine x is equal to 0, it's just now a multiple of 2 linear factors, or cos x is equal to 2. Now cos x can't be equal to 2. We've seen the cosine curve. The cosine curve has a maximum value here of 1 and a minimum value of -1. It can't be 2. Therefore, all we need to do is solve sine x is equal to 0. And with the sine, when you can do this visually, you can see this from here. We've got 0, we've got 180, we've got 360. So x is going to be equal to 0. We've got now 180, and we've got 360 degrees. So that is done. Just be aware of that. Okay. Now the next one, what we can do, there are a couple of different ways of solving this. We can actually right that 2x minus 10 is equal to 50, but we also have to consider the symmetry of the curve, and also we have to consider the period. I suggest you don't use that approach. You could do. What I'm going to simply say now is that 2x minus 10 is equal to the inverse sine. Now, if you think about this now, when we say this, the inverse sine of sine, that's just simply going to give us now the 50 degrees. So sine to minus 1 of sine of 50. So that's what we're going to write. So what we've got then is 2x minus 10 will be equal now to 50 degrees. Plus or minus 360 degrees. So multiples. 2x minus 10 will be equal now, if we just consider what we've got here. We've got on here now 50 degrees back from 180 by symmetry, which is going to be 130 plus or minus 360. So at this stage, what I'm going to do is simply write now on here that x is going to be equal to 50 plus the 10 divided by 2 plus or minus multiples of 180 degrees. X is going to be the 130 plus 10 divided by 2 plus or minus multiples of 180 degrees. So what are we going to get? That's going to give me now 30, that's 60, 30. So x is going to be equal to 30 degrees. Then we're going to have now 30, so that's another 180 on 210 degrees. This one right here, x is going to be 140 over 2, which is 70. And then we're going to add 180 to that, which is going to give me now 250 degrees. All others will fall outside the interval. So you can be cheeky and just write 2x minus 10 is equal to 50, but don't forget this. Often students just put the answer as 30 degrees. The inverse sine of 50 degrees is going to give us that value, but we need to consider subsequent solutions. Okay, so let's go ahead and do this right here. So what we're going to have on this one is the following. We're going to have 3 theta minus 20 degrees is equal to the inverse tan of the tan of 30 degrees, which is going to be 30, and then we're going to have plus or minus 180 degrees. We've got multiples, it's tan, cycles every 180. So what I'm trying to get across is, don't just say, well, if the sine of this is equal to the sine of that, that's equal to that, and just go ahead and say that it's 30. There are going to be subsequent solutions by symmetry and by the fact that the curve cycles. So let's write this out. Theta is going to be equal to 30 plus 20 divided by 3 plus or minus multiples of 180 divided by 3, which is going to be 60 degrees. So what's 50 over 3? 16 and, what is it, 16 and a third? Let's write that out. 50, so 50 divided by 3. 50 divided by 3, 16 and 2/3, so 16.7 theta. You can see how my brain is frazzled. 16.7, and that's to 3 significant figures or 1 decimal place. 16.7 degrees. And now we're just going to be adding multiples of 60 degrees. There's going to be a whole load of these. So what's the next one going to be? 76. So this is the last equation, so hopefully I'll get through it. 136.7 degrees. 196.7 degrees. We're going to have the next one, which is going to be 256.7 degrees. 256.7, that's what I want. And then the next one I need to add, so what's that going to be? 316.7 degrees. So there we go. They are the solutions in that interval. So just on 54 minutes of talking, lots of different equations. Hopefully that's been of some use. Again, you can use any method you like. That's the method I like. And there we go.